Welcome to the Tissue Array Advanced Techniques video. We will be covering some specific topics for advanced tissue microarray construction. In this video, I will only touch on the basics of array construction. If you are a novice at doing tissue microarrays, please refer to the instructional video, Introduction to the Tissue Arrayer, for punching techniques, array layout, and documentation. In this video, I will be explaining some new and improved ways for using the Beecher Instrument Tissue Microarrayer. These techniques can also be used with other TMA instruments on the market. I will be covering the block warmer or punch assist. I will also explain two different ways of using small amounts of tissue for array construction, which I call scrapings or the scraping technique. Many array technicians have asked me about array block cutting techniques, so I will go over some basic micronomy techniques for cutting tissue microarray blocks. First, the block warmer. I call this the punch assist because it enables a technician to punch many size needles into paraffin with little or no resistance, thus keeping paraffin buildup to a minimum. I have found this simple remedy to be a crucial element in every array that I construct. The instrument is very simple. It consists of heat strips glued to the aluminum recipient block holder. The blue wire is the thermostat, and this is the control box which regulates the heat. I am providing close-ups for those who would like to build a punch assist for themselves. If you would like to test this concept, place a blank recipient block into a 40-degree water bath for about 15 minutes. Then punch your array until the block is cool. This is how I first learned of the advantages of the warmer method. From these two array blocks, you can see a significant difference. When looking close at the room temperature block, you can see the paraffin buildup. The compression from every punch builds up until it creates a small hill in the middle of your punch group. When you look closely at the recipient block created by the block warmer, paraffin buildup is almost non-existent. This is what I will explain in depth so you can see the significance of this simple instrument. Place the array block in the aluminum block holder just as before. The heat strips on each side of the block holder heat the block to approximately 100 degrees Fahrenheit. Different paraffins require slightly different temperatures. It also depends on the temperature of your lab as well. I organize my samples as explained in the video Introduction to the Tissue Arrayer. Grid boxes and charts keep order to reduce error when punching. Also, specific areas are marked on a corresponding H&E slide for accurate punching. When you first punch into a warm array block, you will notice immediately the lack of resistance as the needle slips into the paraffin. When you insert the core, you will feel how flat the recipient block is. Pay attention to how hard you press with your finger. The paraffin is soft and will tend to dent if you are not careful. Now I am punching a room temperature recipient block. If you look closely, you can see the paraffin buildup around the needle. This is normal for punching at room temperature. From the side view, you can see the paraffin mounted above the surface of the block. I will now place the same block back in the block holder with the warmer on. I will let it sit for approximately 15 minutes to get the block up to punching temperature. Once punched, the side view shows the difference. It is obvious that the warm block will allow the needle to insert better and the surface to be flatter. The 2mm needle is no different, except that the room temperature block shows the compression problem is more exaggerated. But with the block warmer, the compression is to a minimum. Because the block is warm, it sometimes takes several tries to remove the core. Tapping on the stylet and moving the rod quickly usually breaks the core free. Periodically, as I punch, I will place a glass slide on the array block to keep the punches evenly flat. Remember again not to push too hard with the slide. The block is soft and will tend to dent or warp. Once the array is finished, I will again press the slide on it gently. I do not remove the array block from the warmer yet. I place a glass slide in an oven at approximately 85 to 90 degrees Celsius for about 15 minutes or until it is hot. Now I remove the block from the block holder. While the block is still warm, place the hot slide over the block and watch the paraffin turn to liquid. Move the slide around to make sure that the bubbles are gone. This step cannot be accomplished with a room temperature block. Melted paraffin will not stick to a cool block surface. Because the paraffin is warm and soft here, the liquid paraffin will stick. You don't have to press a slide to the block to set the punches. While you're punching, your array cores were setting to the soft paraffin. This eliminates the warping problem caused by pressing the block to the slide after removing it from the oven. The oven step here is removed. When the block is slightly cooled, turn it over so the temperature of the tabletop will continue the cooling process. After a few minutes, place it on ice to cool before trying to remove the slide from the block. Again, the oven step is eliminated. No more pressing of the block to the slide. This method also reduces the need for excessive trimming, as you will see later. Warping was very common when doing arrays the conventional way. Now with warm blocks, the rows are more even, which makes it nice for the slide reader. I have found two techniques for using the scraping method. One, digging the tissue out with a donor needle or digging the tissue out with a razor blade. I have used both methods and found no difference in their success rate. Both give good results. Again, the slide is marked, noting the area. When I first experimented with small amounts of tissue for arrays, I tried to use a punch fill method like this. I found this method to be inconsistent. Punching shallowly put gaps of paraffin in the tissue cores. The scraping method mixes up paraffin and tissue, leaving most of the core sections with tissue. Sometimes the sections are irregular, but still tissue is present. And it is a deep core, which is also better than a shallow core. Here is a diagram comparing a punch fill with a scraping core. The punch fill has tissue only intermittently, while the scraping has tissue throughout. Razor blade technique. I used the razor blade technique more when I first experimented at using small amounts of tissue for array protocols. It is a very simple procedure. Take a razor blade and gently Cut out the area of choice. Try not to dig out any blank paraffin. Stay in the tissue area. Place a small scraping of tissue on the array donor block bridge. Bring the donor needle down and start to fill the needle as you would fill a straw with ice. Try not to push too hard because you don't want to damage the needle while doing this. Maneuver the block bridge around to keep the tissue in the middle for the needle. After you have filled the needle, place it gently on the donor block bridge. Take the stylet and gently push down several times, packing the fragments into the needle. This will form a solid core to insert. Clean off the donor block bridge and insert the scrapings into your array block. The needle scraping method is done a bit different. Remove the donor needle from the arrayer. From the selected area, dig the tissue out of the block. Not in the way you would do a punch fill, but by scraping the tissue surface area, filling the needle slowly. Avoid any blank paraffin. This is actually faster than the razor blade technique. It depends on what you feel comfortable with. Some people may want to dig the tissue out using a razor blade because the instrument is larger in your hands. The needle is small and takes practice digging with. When you have enough tissue, place the needle back in the arrayer. If you are gentle, the donor needle will still be straight and not bent from scraping. Pack the needle the same way as the razor blade method. Gently bring the donor needle down to the donor block bridge and pack the needle lightly with the stylet. If you push too hard, you could bend the edge of the donor needle, dulling it or bending the entire needle. It doesn't take much to pack the tissue. Now it is ready to insert into the array block. This HER2 new group of scrapings show some of the cores are irregular. This occurs because it is hard to avoid blank paraffin on small fragments of tissue. But without using the scraping method, it would not have been possible to use these tissues in the first place. There are very minimal uses for tissue microarrays in histology at present, but we have used them for controlled tissues. The most significant use has been for antibody optimizing. This EGFR array showed us which breast tissue was positive and which dilution and incubation time was best. One slide instead of 50. There are as many techniques for micronomy as there are histology technicians. I have put this section into the video because I have received many calls on how to section an array block. Not all array technicians are histologists, and even some histologists also have problems sectioning an array block. Once the array block is removed from the glass slide, it is ready to cut. Before I cut an array block, I make sure the edges are square. Riveting is a crucial part in making even, clean sections. I try to avoid soaking an array block in ice water. Sometimes ice water is okay for a few minutes, but not for long periods. Different tissues react differently in water. Array cores are extra sensitive to soaking in that during their initial removal from the donor block, compression damage has occurred. Small cracks are throughout the cores, and water can seep in and cause swelling. I like to take a kin wipe and knock off the edge of a new blade. I know this sounds funny to some people, but I have found that blocks ribbon almost immediately when cutting if the edge is slightly dulled. Some technicians don't like to adjust their chuck. I work with a lot of old blocks, and to conserve tissue, I have developed a habit of adjusting my chuck with each block. An array block is no exception. If you have to trim an array block because it isn't flat to the blade, you will trim away vital samples. The two main tools used by most histologists for picking up sections are, first the forceps, and second the needle probe, or sometimes called the microprobe. The original microprobe was a wooden stick with a needle on the end of it. After you have trimmed the array block flat, which you can see didn't take much because the blade was flat to the block surface, move the blade to a new area. This will eliminate lines in the ribbons caused by nicks in the knife from trimming. Flat block edges make it possible to make long ribbons. I know of two main techniques for picking up tissue ribbons in the water bath, and there are many variations to these basic techniques. Find which works best for you. I don't know if you can tell, but I'm blowing on the sections very lightly as I cut. This helps to pull wrinkles out as I make a ribbon. Forceps are commonly used to hold the ribbon during sectioning instead of your fingers. I use the microprobe to carry sections to the water bath. Forceps are used to carry the ribbon to the water and for tearing the sections apart. This is a very common technique. When picking up sections on a glass slide, try not to touch the tissue. You can maneuver the sections around by touching the paraffin areas. Another technique for picking up sections is using the slide to tear the sections while holding the ribbon with the probe. Then use the probe to maneuver the sections onto the glass slide. This technique takes a little more practice to get used to, but it can be a faster method. The most common type slide used are plus charge slides. Some laboratories use a type of adhesive in their water bath to allow for using regular non-charged slides. Some even purchase chemicals to charge common slides themselves. If doing immunoperoxidase or other tests that require a lot of rinsing of tissue samples, then charged slides are recommended by most vendors. I hope this video answers your questions on advanced array construction. I would recommend that you test the techniques and concepts taught in this video before you add them to your own array construction protocols. We have only dipped into the many uses of micro-tissue arrays, and I believe someday that the tissue array will be as common in the histology laboratory as the microtome.